Digital signal processing filters contain active circuits that can readily help reduce the noise on audio signals. When hams talk about networks, they are usually talking about a circuit between the transmitter and the antenna to match the impedance of the transmitter to that of the feed line antenna combination, or to reduce harmonics. The simplest LC impedance matching network is the L network. The choice of which circuit to use is determined by the ratio of impedances to be matched and the practicality of the component values to be used. This L network will match higher impedances on the input to 50 ohms on the output. To adjust this network, the coil tap is moved from one turn at a time, while the capacitor is tuned for lowest standing wave ratio. The disadvantage of this circuit is that it works best on only one frequency band at a time. A given LC combination has a relatively small impedance matching range. Here is a pi network on the output circuit of a tube circuit. It is used to tune the output circuit to that of the tube. Most tube-type amplifiers use pi network output coupling circuits. When you need more attenuation of harmonics from your transmitter, you can add an L network in series with a pi network to form a pi-L network. The T network is commonly used in antenna coupling equipment because this circuit has lower loss than a pi network. This circuit also acts as a high-pass filter, but provides little harmonic rejection. Cavity filters such as this are used in repeater systems to help isolate the receiver from the strong output signal from the transmitter. Which of the following filters would be the best choice for use in a 2-meter repeater duplexer? The answer is B, a cavity filter. What advantage does a pi-L network have over a pi network for impedance matching between a final amplifier of a vacuum tube transmitter and an antenna? Answer A, greater harmonic suppression. What kind of digital signal processing audio filter might be used to remove unwanted noise from a received single sideband signal? Answer A, an adaptive filter. And now let's look at voltage regulation. A Zener diode's reverse breakdown voltage is fairly constant. Zener diode regulators work best with a constant load. Pass transistors can often be used as the voltage dropping element rather than a resistor. The DC current in the base of a transistor is used to throttle the collector emitter current. This is an example of a series regulator because the pass transistor is in series with the load. A shunt regulator controls the output voltage by controlling the load on the power source. 3-terminal regulators are very popular. One terminal is for the input voltage, one is for the output voltage, and a third terminal is usually for ground. Some can be bought already configured for a specific positive or negative output voltage. Bleeder resistors are used in power supplies to bleed off the charge stored on filter capacitors when the power supply is turned off. Bleeder resistors should reduce the output voltage to 30 volts or less within 2 seconds of turning off the power supply. What is the primary reason that a high-frequency inverter-type high-voltage power supply can be both less expensive and lighter in weight than a conventional power supply? A. The inverter design does not require any output filtering. B. It uses a diode bridge rectifier for increased output. C. The high-frequency inverter design uses much smaller transformers and filter components for an equivalent power output. Or D. It uses a large power factor compensating capacitor to create free power from the unused portion of the AC cycle. Answer C. The high-frequency inverter design uses much smaller transformers and filter capacitors for an equivalent power output. What is one purpose of a bleeder resistor in a conventional unregulated power supply? A. To cut down on waste heat generated by the power supply. B. To balance the low voltage filament windings. C. To improve output voltage regulation. D. To boost the amount of output current. Answer C. To improve output voltage regulation. What is one characteristic of a linear electronic voltage regulator? A. It has a ramp voltage as its output. B. It eliminates the need for a pass transistor. C. The control element duty cycle is proportional to the line or load conditions. D. The conduction of a control element is varied to maintain a constant output voltage. The answer is D. The conduction of a control element is varied to maintain a constant output voltage.